Hi, everyone. We'll continue where we stopped with the data preparation and cleaning for survey data. So let me share my screen very quickly. So this is the data set where we stopped. We already defined our and we labeled our columns for the data set based on the data dictionary. And now let's do some more cleaning of our data. Let's start with deleting the columns that have no values here, the null values or the blank surveys. So to do that, let me select this whole first row, and then let me sort from large to small that way. Yes, expand. Now I removed those empty ones to some extent, and I still have some that are not complete, or they have missing values, like for example, this row. Let me see how far it is. So this one, let's say from here, a lot of variables were not answered. So maybe I can also sort from here, just kind of to see which ones. All right, let me see now. All right, so now I can see this guy, this line, I can remove it because several variables were not filled. So I'll remove those two. I'll just delete them. And this guy. All right, so now I have around 209. There are some missing here and there, but those can be, they are not that many missing values. So for example, this guy, it can be automatically replaced by WordPLS. So those missing values will be replaced with the mean or the average of the column, right? Through WordPLS, and it does that automatically. Another thing, while I'm cleaning the data, I need to remove this column that has text in it, because WordPLS, like other software, doesn't like text values for analysis. So what I'm gonna do, I'll keep this guy, but I will create a new one. Let's see here. And I will call it only data only. Let's see here. Copy, and then I will paste it here. So I will call this one data only, or numbers only. And I will delete this, because if I need to do some analysis related to this text, I can always use this sheet later. But for now, I need to get my data ready for analysis, for structural equation modeling analysis, and also for reporting some descriptive statistics. So to do that, now I need to clean my demographic data, demographics. So for demographics, let me see here, starting with gender. As I said, for gender, in the data dictionary, we said we have male, female, and prefer not to tell, right? That's what I did. In this case, I can, and then the male was 1, female was 2, and prefer not to tell was 3. That's kind of the default of, just to double check how it was. Let's look at the survey in Qualitrix, how we answered that question for gender. Let's see. So gender, that's 1, 2, and 3. Just kind of double check, right? So now for gender, I can create new. I will create one variable, and let me also see how many answered with 3. largest to smallest. So I have a couple of who answered 3. So let's say here, we'll use female. So we'll create our own variable. We'll call it female. So here equals, and then we can create an if statement. So if this value equals, so female was 2, then it is going to be 1. The absence of it is going to be 0. This should be enough for us. And then I can just copy it and paste it as values, as numbers, values, right? All right, so now I created my gender to be female, female or else, right? So that should be enough. For age, based on the data dictionary, we had age kind of in an ordinal format. So it starts from 20 or less, 21 to 25. So it's an ordinal variable. So we can keep it as is. So it is, in other words, it is ranked from 1 to 7, going from low age to high age. So we can keep it as is. The same thing for education. Education was from less than high school as 1, high school 2, associate degree 3, and so on. So again, that's we consider that ordinal, so we can keep it as is because it's ordinal or ranked. So for income, let's look at income. Again, it is ranked or ordinal, 30,000 or less, 31 to 40,000, and so on. So that's again, it is ranked. So we can keep it. We will keep it as is. Now for race. Race, we need to specify. We can either specify or we can just keep 1. What is the majority of, in terms of race, where I collected this data? I believe it was Hispanic race. So in this case, I will create my own dummy variable. I will call it Hispanic, because the majority of the race here in this, where we collected this data, was Hispanic. So I will put it as Hispanic, and let's see what was the number for Hispanics. That's 1, 2, 3. So 3 was the Hispanic, and let's just double check here. What was the number for the race? So 1, 2, 3, right? All right, so let's go here, and then I will create an if statement. So if race equals 3, then it is going to be 1. So the existence of Hispanic, which is 3, will be 1. The non-existence of this will be 0, right? So this is just an example. All right. So this should be, and then I can copy and paste this value. So now we should be ready actually to, here, another thing for innovativeness, it was measured in a reverse way. So for innovativeness, this one, so the first question was, I tend to purchase new technologies when they first come out. So that's the highest innovativeness. And I tend to wait until a new technology has been used and reviewed. So that's in the middle. I don't pay any attention whether technologies are new or have not been used. So that's the least. So it is reverse. So this is 1, 2, and 3. And for innovativeness, we wanted to go from low to high, but here it is reverse. So to reverse it, what we need to do is to call it here innovativeness without reverse, which is going to be this number times -1. All right, so that way we can reverse it. Now it is going to be from low to high, and that's how we reverse our indicator. All right. Again, we will just make sure that we remember to use innovativeness just values. I will keep them both here. That way I know this is the reverse with the R and this is the real one, the actual accurate innovativeness. So I'll stop here with this, and then I will come back with another video to do more additional analyses.